Hello everyone and welcome to tutorial number 49 in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. In the last tutorial I discussed about special annotations and restrictions. So we completed the chapter for annotations. Okay, so we have fully covered the concept of annotations. So in this tutorial I'm going to start the new concept of generics, okay, so which is a very important concept in Java. So let's get started right away, and if you want to learn about special annotations and restrictions, then you can refer to tutorial number 48. Okay, so let's get started with tutorial number 49. So first of all, what is generics? Okay, generics are, they are kind of parameterized types, okay, which are defined in a class. Okay, so when I show you the example, it will be more clear to you. Like for example, if you look at this second last point, for example, class gen, then after that you can see the difference here. Okay, how this particular class is defined. The name of this class is gen. Then after that, we have this angular bracket. Okay, so less than bracket. Then after that we have this t. Okay, this t refers to the parameterized type, or we can even call it the type parameter. Okay, then after that we are closing this particular bracket. Okay, so this t, it is the type parameter or parameterized type, and it can be replaced with anything else. So I mean, it can be replaced with string, it can be replaced with integer, it can be replaced with a boolean. Okay, it can be replaced with runnable also, it can be replaced with thread also. There is no limit to what this t can be replaced with. Okay, so because of this reason it saves a lot of typing. Okay, now think about it for a second. If I am defining gen runnable, okay, then after that I am defining gen thread, then after that I am defining gen okay, let us say integer, then for each and every time I am defining the same class again and again and again. Okay, so if I use generics, okay, using this particular t, it is going to save a lot of typing. Okay, it is going to save a lot of typing because I need to define this class exactly once, and whenever I am creating the object of this particular class. Okay, so we will be discussing how to create object of this class and how exactly the syntax is going to look like, okay, in the next slide. So in that you will understand that we need to define this class exactly once, but we can create as many objects of this class, okay, as we like. Then after that, the class which is operating on the parameterized type. Okay, so this class gen, okay, name of this class is gen, it is operating on the parameterized type t. So that means this gen class, it is a generic class. Okay, now one thing to remember is that generics, they are very similar to templates in C++, but one you need to remember that even though they are similar, both of them are not equal to each other. Okay, so I hope you understand that even though generics are almost similar to templates in C++, both of them have differ from each other in a lot of ways. Okay, both of them are not the same. Okay, then as usual, I already told you t is type parameter. Okay, so let us go to the next slide. So now in this tutorial, in this slide, we are going to discuss how to create object of the generic class. Okay, so for example, here the class name is gen, okay, with the type parameter is t. So instead of t, I am replacing t with integer. Okay, gen is the name of the class. Instead of t, I am writing integer. I can write whatever I want to write here, because there is absolutely no upper bound or lower bound here. Okay, so we'll be discussing about the concept of upper bound and lower bound very soon. Okay, so you can write any class name here. Then after that, gen, it is obviously, it is the reference. Okay, gen refer, it is the reference of this particular class. It is equals to new gen integer. So this is how new gen integer, this is how we create the object of a generic class. Now one thing you need to keep in mind is that if you are using integer in the left hand side, that is what I have written in the second point. So if you write integer in the left hand side, then you need to write integer in the right hand side as well. Okay, you cannot write integer here and you can write string here. No, it is not going to work. In much the same manner, you cannot write string here and you cannot write integer here. That is also not going to work. If you are writing integer in the angular bracket, okay, in the left hand side, then you need to write integer, okay, in the angular bracket in the right hand side as well. Okay, whatsoever class name you're writing in the left hand side, the same class name has to be written in the right hand side as well. Okay, if you don't, if there is a mismatch, then the compiler is going to throw an error. Okay, so you need to keep that in mind. And generic, it is going to work only on objects. Okay, so that means, what I mean by this particular statement is that, okay, this integer, we know very well that this is a type wrapper for the int primitive data type. So this generic, it is going to work only on classes or objects. Okay, so you can write only integer here, you cannot write int here. Okay, int, remember, int is a primitive type. Okay, it is a primitive data type. Okay, but integer, it is a type wrapper. So you can write only integer in the generic angular bracket. Okay, you cannot write int here. In much the same manner, you can write character inside this. Character is a class in Java, remember that. It is a type wrapper for the char data type. And so you cannot write char here. That is not going to work. So that is the meaning of this third statement. It is going to work only on classes and objects. Okay, so you need to ensure that you write only the name of the class inside this angular bracket. Alright, then after that, generic, it is going to be invalid on primitive data type. Okay, so that thing I already told you cannot write int here, you cannot write char here. Okay, so these are all primitive data types. So that is what I have told in this particular example as well. Okay, so I think it is the fifth line. Okay, so gen equals new gen int, it is not allowed. Why it is not allowed? Because int, it is a primitive data type. Okay, so this int, it is not going to be valid. Okay, then after that, this last point is slightly different. So what I'm trying to tell you here is, okay, let us assume that I am this gen. Okay, I am referring to this particular gen of the first line. Okay, because here also I am define gen, but actually this is going to give an error actually. Okay, so I am not referring to this gen, I am referring to gen of the first point. Okay, so now look at the second last point, gen. Okay, this is the name of the class, then string str equals new gen string. Okay, so here I am using the type parameter string. Okay, in the second in the first line or point, I am using the type I am using the integer as the what I am saying as the parameterized type. Okay, so now this str, okay, this str, it is it is an object of gen with the parameterized type string, and this gen, okay, gen, it is the object of this class with parameterized type or type parameter integer. Okay, so obviously gen is not going to be equal to str, it is not allowed. Okay, because str has the type parameter string and gen has the type parameter integer, so both of them cannot be equal to each other. Okay, so this thing is not allowed. However, let us say that instead of integer, if I replace this integer with string, both in left hand side and right hand side, then in that case it will be valid. Alright, so you need to keep this thing in mind, even though it is the object of the same class. Okay, even though it is object of the same class, okay, because this is class is generic, you need to take care of the type parameter as well. Okay, so if this gen, it is the object of this class with type parameter integer, and this str, it is the object of this class with type parameter string, so both of them are not going to be equal to each other. So this particular line str equals to gen, it is going to give a compilation error. Okay, so then after that we have type safety. So generics, they are going to ensure type safety. In other words, you can call type safety as type compatibility. Okay, like for example, if you want to store an integer value in an int data type, okay, or if you want to store let us say a double value inside a double data type, so something like that. You should also remember that you can even store a float value in a double data type, okay, if you remember. Okay, so that is what type compatibility is all about. Okay, so it is going to ensure that integer value is not going to get stored in string, because obviously it is not going to work. Okay, you cannot store an integer value in a string variable. I cannot write a string str equals to 123. Okay, of course if I put double quotes over 123, then it's a completely different thing, don't get confused. Okay, but here we are talking about type safety with generics. Okay, so this thing will be more clear when I use the IDE. Okay, but this generic is going to ensure type compatibility. Okay, and it is going to throw compiler error if any type incompatibility is present. Okay, so I think I cannot explain it here. Okay, but it will be more clear when I use the IDE. Okay, but generics, it is going to ensure type compatibility. So that is what this particular slide is saying. Okay, so then after that we have the generic class with multiple type parameters. Okay, so the very first generic class which I defined here, okay, here gen t, it had a single type parameter. Okay, but however there is a we can even define generic class with more than one type parameter. Okay, so this is what this class is all about, gen tu. Okay, so t is one type parameter, u is the second type parameter. All right, then after that, how to create an object of this class? This is also very simple. Okay, first of all we need to write gen, then string integer. Okay, string integer, actually it is not mandatory to write string integer here. Okay, as I told you earlier itself, you can write whatsoever you want to write here. Okay, because this is a generic class, so you can write whatsoever you want to write here. The compiler is not at all going to give you any kind of errors. And another thing is, there is no upper bound, there is no lower bound. Okay, so once again you have full freedom whatsoever you want to write here. Okay, instead of string you can write integer here, and instead of integer you can write thread also here if you want. Okay, it all depends on what logic you're writing, or what logic you're trying to build in the particular program. All right, then after that gen, this is the reference of this particular class. It is equals to new gen string integer. Now another thing, I'm repeating the same thing which I repeated a couple of slides ago. If you're using string integer here, then you need to mandatorily write string integer here. Okay, you cannot write anything apart from string integer here. That's what I'm trying to say. Okay, if you're writing, let us say, thread runnable here, okay, for some strange reason, then here also you need to write thread runnable. Okay, in much the same manner, let us say you are writing scanner here. Okay, scanner integer or something like that. Okay, then you need to write scanner integer here. So what I'm trying to say is, what are the name, whatsoever you are writing the name of the classes in the left hand side, the same name has to be repeated in the right hand side as well in the same order. Okay, so here if you're writing string integer, then here also you need to write string first, then only you can write integer. Okay, it's not that you can write integer first, then after that you can write string. No. Okay, so please keep those things in mind. Okay, then after that we have the bounded types. So finally we are going to study about what is upper bound and lower bound and all those things. Okay, so now what this bounded type is going to do is it is going to limit a type which is passed to a type parameter. All right, so for example here I am writing class t extends number. Okay, so this particular t, okay, whatsoever I am passing as a parameter to this particular class, actually I have not named the class properly here. Okay, so now what is this class going to do is, it is going to accept only type parameters which are extending from the number class. Okay, so it is t is going to be only the subclasses of number. Okay, this thing will be more clear when I use the IDE, but okay, but right now you just need to assume that t is going to accept only subclasses of number. Okay, like for example we have integer, we have float, double, long, short, byte. Okay, all these are type wrapper classes, and all of these are going to be accepted by T. T can be replaced by all of those values 1, 2, 3, 4, 5, 6. Okay, so it can be replaced by any one of those 6 classes. Okay, so this is the thing which you need to keep in mind. Here the number, it is the upper bound. Okay, so a number is the upper bound, and T can be accept any subclasses of number. Subclasses mean child classes of number class. Okay, and using any other classes apart from that, it is going to give a compiler error. Okay, so you cannot write class thread here. Class, I'm saying class, actually I did not name this class properly, so let us say class generic. Okay, gen, class gen, then after that we have this angular bracket. So you cannot write gen thread, that is not going to work. You cannot try to create object of gen thread, because thread is not extending from number, right? So it is not going to work. Okay, so this T can only be integer, float, double, long, short, or byte. Okay, then after that we have wildcard argument. Okay, wildcard argument, now as the name itself might suggest, actually this is a kind of method argument. Okay, so like for example, now if you look at the second second point, it will be a little more clear to you. Instead of using T, instead of using U, or instead of using V, we are using question mark here. Okay, we are using question mark here. Okay, now why this particular wildcard argument is used? Okay, this thing, it will be more clear when I use the IDE, but generally, you know, why I use this wildcard argument is because I want to compare two objects of class, okay, with each other. Okay, in this case I am comparing two objects of the same class stats with each other. Okay, so now one thing will you know, doubt will arise in your mind, that why I am using question mark here, why can't I use T here? Okay, so you need to remember that okay, that if I am comparing let us say this integer object of this, I am comparing int stat with double stat, let us say. Okay, int stat, it is the object of this class stats with the type parameter integer, and double stat, it is the object of this class stats with the type parameter double. Okay, so now the thing is, I want to compare int stat with the double stat. Okay, so okay, if I am comparing int stat with double stat, it is actually going to create a problem. Why it is going to create a problem? The reason is because int stat has the type parameter of integer and double stat has the type parameter of double. Okay, if it is if the both the objects are having the same time parameter, then you don't even need to use wildcard argument. Okay, obviously this thing I cannot explain it in much of depth with the help of the PPT. Okay, so this thing will be more clear when I use the IDE. Okay, so let's leave it at that. Okay, but you need to remember that if I am comparing int stat with double stat, okay, then it is better to use wildcard argument, okay, instead of a generic argument. Okay, so we will be covering the rest of the concepts in the IDE, and after that we have bounded wildcard argument. Okay, bounded wildcard argument is the same thing. Okay, wildcard argument only, but with the upper bound or a lower bound. Okay, upper bound means here I am writing stats. Okay, question mark extends number, then stat. So that means this question mark extends number, this particular class, okay, it can accept only you know, those type parameters which are, you know, directly extending from the number class. Okay, question mark can only be subclasses of class number. That is the meaning. Number is the upper bound here in this case, and question mark can replace it with only the subclasses of class number, not with any other class. Okay, and in much the same manner, if you look at the third point here, stats question mark super long. Okay, so this particular question mark super long, this is a kind of lower bound. Okay, long is the lower bound actually here. Okay, here question mark extends number, number was the upper bound, but here long is the lower bound. Only super classes of long are acceptable. Okay, now if you remember, the super class of long is number. Okay, so number is acceptable, and the super class of number is object, obviously. Okay, so you know, so these kind of super classes are acceptable. Okay, so here you can write either stats number, or you can write stats object, something like that. Okay, here long is the lower bound, so you can, question mark can accept only super classes of long. Okay, then after that we have a generic method. Okay, so generic method, we can create a generic method using this way. Okay, first of all you need to write public, then after that you need to open the angular bracket. Okay, you need to write it t or u or v, whatever you want to write here. Okay, here I am defining only one type parameter, void swap. Okay, return type of the method is void, swap is the name of the method. Okay, TATB, here the t, it is the type parameter. Okay, so the beauty of this particular method is that I can use this to swap any two objects. Okay, any two objects means, okay, whatever object I have in Java, like any two objects can be swapped with this method. Okay, I don't need to create a separate method for swapping two, let us say, integers. I don't want to create a separate method for swapping two strings. I can use the same method for swapping integer. I can use the same method for swapping two characters. Okay, for swapping two booleans. Okay, like that. This same method can be used. That is why in the very first slide itself I told you that this generic method, or even this generic itself, okay, it is going to save a lot of typing. Okay, so it is going to swap any two objects. Then after that, in much the same manner, the generic method can also define upper bound and lower bound. Okay, so if I am defining upper bound, I am going to write t extends number here. Okay, let us say I want to swap only two numbers, then I am going to use this particular line. Okay, I am going to use this upper bound. Okay, if I don't want to use this upper bound, then it is completely up to you only. Okay, so then after that we have the generic constructor. Even a constructor can be generic in Java. Okay, like for example, here I have defined the class named gen. Okay, then remember this particular class, it is not generic in nature, it is not accepting any type parameter. But this particular constructor, it is generic in nature, because first of all I am defining angular bracket, opening and closing angular bracket, t extends number, then after that gen, it is the constructor, then it is accepting a parameter t obj, and this t, it is a type parameter. Okay, so you need to define constructor in much the same way as a method only. Okay, first of all you need to define the type parameter. Okay, so this particular thing shows that this is a kind of upper bound, so you can use this if you want, but even if you don't use it, it is not going to matter. Okay, it is completely up to you what logic you are trying to build. Then after that, gen, it is the name of the class, obviously, so name of the constructor has to be the same as the class name. Then after that, t obj, t is referring to the type parameter. Okay, so this is a kind of generic constructor. Then after that we have a kind of generic interface as well, and I think this is the last slide. So generic interface, okay, even a interface can also be generic in Java. Okay, so how to define a generic interface? It is very simple. You just need to define interface, then after that you need to write gen. Okay, gen means it is the name of the interface. Okay, you can write whatsoever you want to write here. Then after that you can open the bracket, okay, angular bracket, then after that you are writing the type parameter. Alright, so this is a kind of a generic interface. Alright, so you can even write upper bound also. Okay, you can define upper bound, t extends number. This will ensure that the t can only be subclasses of number, as I told you earlier itself. Okay, so these are the two ways to define a generic interface. I think you can even use lower bound as well. Okay, so these things will be exploring in more detail when I use the IDE. Okay, so then after that, obviously interface means a class has to implement this particular interface. So at the implementing class, it may be generic, it may not be generic. Okay, implementing class may be generic or non-generic. Okay, it is not mandatory that the implementing class has to be generic. Okay, it is optional, it is completely optional. It is up to the logic of the programmer. Okay, whatsoever he wants to do. Okay, if he wants, he can create a generic class. Okay, otherwise he can create a non-generic class as well. Okay, so in the first example, what I have shown you in the next point is the implementing class is generic. Okay, class imp. Okay, imp, it is the short form for implementing. So imp t implements gen t. Okay, so this particular class IMP, it is implementing this interface. Okay, and this class is also generic in nature. So this is one of the way to implement this particular interface. And the second way to implement this particular interface is to create a non-generic class IMP. Okay, now remember, IMP, I am not specifying any type parameter here. That means this is non-generic in nature. All right, then after that we have implements gen integer. Okay, gen integer, why I'm writing gen integer is because you if you look at the last point, it will get more clear to you. Class IMP implements gen t. This thing, it is illegal, it is not allowed. Okay, if you try to write this particular statement in your IDE, okay, or let us say in a program, and if you try to execute it, you can do it right now. Okay, I have no objection to that, you can do it. Okay, but what you will find is this statement is not going to get executed. The reason why it is not going to get executed is because the compiler doesn't know what what is the definition of t. It thinks that t is not defined. Okay, but this thing is completely valid in the fourth point. Class IMP t implements gen t. This particular statement, it is not going to give you any kind of error. Okay, it is going to execute just fine. Okay, but this last line, it is not going to work. Okay, why it is not going to work? Because there is no t in the implementing class. Okay, that is why you need to write like it is shown in the fifth point. Class IMP implements gen integer. Okay, you need to explicitly mention what the t is going to be replaced with. Okay, if you're creating a generic class, implementing class is generic, then it is not an issue. Okay, but if the implementing class is non-generic, then you need to explicitly mention what the t is referring to, whether it is referring to integer as it is shown in the fifth point, or whether it is referring to character, or whether it is referring to double, or whether it is referring to thread, or whether it is referring to runnable, and so on and so forth. There are so many classes in Java. Okay, so I cannot keep explaining each and every class, so it is completely up to you what logic you want to use here. Okay, so that's all we have to talk about generic interface. So that's all I'm going to talk about in this particular tutorial as well. If you have any kind of doubts or any kind of questions, then don't forget to post in the comment section below, and I will get back to you when I can. And if you liked this particular tutorial, then don't forget to like, share and subscribe. And yeah, I will see you in the next tutorial. So till then, bye.